Alright, today we're learning about two variable inequalities. This is just a little prerequisite before we get into all about learning target 3. So we're going to talk about what these signs mean below and how do these affect the graphing of a linear inequality. So you should know that this sign here is less than, and this sign is greater than. Just remember, if you make that little shape with your hand for less than, it always shows you an L, okay? So that would always be less than. These two signs here are going to give you a dashed line on the graph, okay? So a little dashed line when you're graphing your lines. For greater than or equal to, and then less than or equal to, these would actually be solid lines. So when you see the line underneath, make sure it is a solid line. We'll talk about what that means a little bit more when we get into these. So graph each inequality. So this is just like graphing a line. Okay, you got to remember where we had our B point. So our y-intercept, -1, that's what we're going to graph here. Okay, so -1 is our y-intercept. So that goes on the y-axis at -1. And then I have a slope. My slope is right here, 3x. So remember, if it's not a fraction, you just put 3/1. So, and it's positive, so that we're starting from our y-intercept point. We're going up 3, right 1, up 3, right 1, up 3, right 1. Then we'll go back to our y-intercept point. We'll go down 3, left 1. Okay, so now we need to look at our sign. So our sign is greater than. Okay, since it's just greater than, it would be a dash line. So what that means is we're just going to not completely connect the dots. Okay, so now that it's greater than, you would have to shade it, but you need to make sure of which side because it's greater than. So we're going to always use the point. So we'll say it's a test point of 0, 0. Okay, so I'm going to plug 0 in for y and 0 in for x and see if the statement is now true. So I would get 3 times 0, which is 0, and then 0 minus 1, which is -1. So 0 is greater than -1. That is true. So if it is true, then we are going to shade that way. Okay, it's greater than. So we would shade on this side. Okay, where 0, 0 is on that side. Okay. For example 2, I have 2y is greater than or equal to 4x minus 6. So I first need to get y by itself. So to get rid of this 2, I need to divide both sides by 2. So I would get y is greater than or equal to 4x divided by 2 to give me 2x, and -6 divided by 2 to give me -3. Now I can begin graphing this. So -3 is my y-intercept. I'm graphing -3, 1, 2, 3. And then 2x is my slope. Slope is 2 over 1. It is positive. So I am going to go up 2, right 1, up 2, right 1. Continuing that pattern. Back to my y-intercept point, I'm going down 2, left 1. Now, if I look back at my equation, it's y is greater than or equal to, because I have that line underneath. It is going to be a solid line. Okay, and we'll use our test point to make sure it is accurate. Okay, so now we're going to take our test point 0, 0 and plug it in to the equation. So 0 for y and then 0 for x. So 2 times 0 minus 3. Okay, so that gives me 2 times 0, which is 0 minus 3. So 0 is greater than or equal to 2. So that is correct. So we would shade on the side where 0, 0 is. So that means where it's shaded that those could be all possible solutions. All right, example 3. I need to set this equation. We'll get y by itself, so I'm going to get y by itself by subtracting 5 from both sides. Get negative y is greater than x minus 5. Now I need to divide by negative 1. Okay, your y always needs to be positive, so that cancels out. I get y is, whenever you divide by negative, you need to make sure that you're always flipping the sign. So I flipped my greater than sign, it's now a less than sign. X divided by negative 1 gives me a negative x. Negative 5 divided by negative 1 gives me a positive 5. So this is now what I'm going to be graphing. So graphing our y-intercept first, which is a positive 5, and then our slope next, which is negative x, so that would be negative 1 over 1. So starting with our y-intercept, 1, 2, 3, 4, 5. It's a negative, so I'm going to go down 1, right 1. Okay, and it would be a dashed line because there is no line underneath my less than. Use our test point. 0, 0. 0 is less than negative 0 plus 5. So it'd say 0 is less than 5, which is correct. So shading below. All right. For example 4, I have 2x minus 5y is less than negative 10. So solving for y, I'm going to subtract 2x. I get negative 5y is less than negative 2x minus 10. Now I'm dividing by negative 5. Again, because I'm dividing by negative, I need to go ahead and flip that sign. I get y is now greater than negative 2 divided by negative 5 actually turns into positive 2/5 x. And then negative 10 divided by negative 5 turns into a positive 2. So graphing this, y-intercept of positive 2, slope of 2 over 5. So if I started to graph this, graphing my positive 2 first. Now my slope's going up 2 over 5, so 1, 2, 1, 2, 3, 4, 5. Can't go over anymore, so I'm going to go back to my y-intercept and go down 2, left 5. And it would be a dashed line. Okay, so I'm using my test point of 0, 0. So 0 is greater than 2 fifths times 0 plus 2. So 0 is greater than 2. That is false. 0 would be less than. So because it's false, that means I'm going to shade on the opposite side of where 0, 0 is not. So if I picked a point on this side where I shaded, so if I pick the point, this point right here, so that is 3, 0, or 0, 3, sorry. If I plug that in, then my point would be correct. So if I plug in 3 for y, 2 fifths times 0 plus 2, I get 3 is greater than 2, and that works out. So that's how I know that these solutions over here work, okay? And that is how you solve graphing linear inequalities, okay? If you have any questions, send me a message. Otherwise, have a great day.